All right, so just to go through this quarter one final exam review packet with you, I think this will be a nice opportunity for us to kind of go through some of the problem areas, and I'm just going to try to anticipate. Obviously, feel free to email me if you have any questions beyond this, but hopefully this will give us a chance to at least tie up some loose ends before we come through and take this quarter one exam here Thursday and Friday. All right, so you can see that the first part, it says no calculators, but you can kind of scratch that. Calculators will be allowed on the entire test. So that's a little bit of a relief, but there's a warning with that. Please don't get caught trying to do everything in a calculator. You just won't have enough time. Almost all of these problems can be done completely without a calculator, and I'd encourage you to try without a calculator first. And so you can see they kind of move through. In the part one, they talk about transformations and the slope of a line. So these are all pretty straightforward, just kind of moving us through what we've done so far this year. Equation of a line with a slope. A lot of these you can match up and have the correct answer with no work shown. But just a reminder, if we're going after the extra credit on this quarter one exam, we are going to want to show some scratch work for every single problem if we want to get that 3% bonus. So I'd encourage you to do that. It's also very, very good review. So the first page I think generally goes very, very well. I'm not going to spend any time on that one. Again, if you have other questions, please feel free to email me those as they come up. Solving the system, these you can choose substitution or elimination. All you have to do is bubble in your answer, so really that's up to you. And so these, again, not really a whole lot to do. You guys did very well with this when we had our Algebra 1 review at the start. Find the vertex of the parabola. Just remember we're shifting here, so negative 5, 5. So pretty easy to use the shifts when we're in vertex form. Vertex form, or finding the vertex if we have intercept form here, notice there's no second power. Remember that we take the two solutions and we average those to find our AOS. So negative 3 plus 1, we add them up and divide by 2, we get negative 1. So I know it can't be B and it can't be A. And then all we have to do is plug that negative 1 back in for X, and we'll get our answer for Y. So Y equals negative 4 times negative 1 minus 1, that's negative 2. Negative 1 plus 3, that's positive 2. So negative 4 times negative 4, positive 16. And since you have a calculator, if you wanted, you could graph this to see where that vertex would be if it was up above, up above the y-axis or x-axis or down below. But again, I think it's much faster just to do the work by hand, personally. All right, and then number 12, another vertex form. We should be thinking positive 6, negative 3. Boom, C, done. So a lot of the work that we did in chapter 2, you can start to see that surface. Okay, number 13, remember opposite of B over 2A, we have to find the AOS first since this is standard form. Opposite of B over 2 times A, that's 2 times 2. So a positive 1, it can't be D, can't be A. And if I plug in a positive 1, 2 times 1 minus 4 times 1 plus 1, I've got a negative 2, positive 1, has to be C. And I'm hoping that if... First of all, I'm hoping that most of you attempted this on your own, but hopefully as you're going through and checking your work with the back, I'd probably go through one page at a time and check the key with that, and then just see what's going on there. Hopefully that's answering your questions well enough for these pretty simple problems along the way. All right, axis of symmetry, that's the same stuff that we've covered. Opposite of B over 2A, opposite of B over 2 times negative 1, that's negative 2. So B, and this would suffice for having work shown for that problem. Just how are you thinking through it? I just want evidence that you didn't copy from the key that I gave you. 15 is one that has given us a little bit of trouble so far, and there was one of these that showed up on our recent quizzes that we took in chapter 3. So just remember, we cannot solve by factoring unless we have that function in standard form set equal to 0. Okay, I have to do the slants here. 2 times 10 is 20. My magic numbers are going to be negative 5 and a negative 4. They multiply to be positive 20. They add up to negative 9. All right, and so I'm going to take those and look at what's the easier one to work with. I'm actually going to choose the negative 5. So I want my outside product to take something from the 2 and something from the 10. a factor out of each to make a -5. That's a 1n times -5. 1 times -5 gives me that one magic number. And then I'm just going to march through FOIL. N times, let's see, I needed to make 2n squared. That has to be 2n. Something times -5 had to make +10. That has to be a -2. Quick check on the inside. -2 times 2 is my other magic number, -4. So what are the solutions coming out of those factors? Well, this will give me n equals +2. Hey, that's good. That's all I really need. My answer is A. It's the only one that has +2 for an answer. But a quick check here, I would add 5 and divide by 2 to solve that second factor equal to 0. There's my +5 divided by 2. All right, 16 is a bit of a dark horse. Using the graph, what is going to give us the solutions if we were to set that function equal to 0? Just remember, that means 0 height. We're looking for x-intercepts, -1 and +3, just looking at the x-axis. All right, for 17 and 18, I'm going to give you a little bit of insider advice here. We should know how to do these, but remember that the calculators have that if you hit second and then the decimal point, they allow you to type in expressions with I. So I would just be typing this into a calculator. It's so fast to type in, it would save me from doing any little silly mistakes along the way. All right, let's see. We just want to go one page here. And then you can see the part 2, again, we're allowing calculators on the entire test, so this doesn't really apply. If we wanted to evaluate this, we just have to follow order of operations. This is actually one that causes people some issues, or it has in the past. So when we go ahead and lay this out, we'll substitute in our values 3 times the absolute value of -4 minus 3, and then minus c is -2 at the end. We've got to clean up a grouping. That absolute value is grouping. So -4 minus 3 is -7 in there, and then -2. Then before I can start multiplying, I need to say what is the absolute value of -7. It's +7. 21 minus 2, answer is B. But just remember, we cannot multiply this 3 into the absolute value until we've actually figured out what the absolute value is. We can only multiply two numbers together. Can't do that while those absolute value walls are in the way. All right, evaluate. Again, a pretty straightforward problem there. Calculator allowed definitely helps with that. Another evaluate, just kind of given differently. Remember, we are plugging in 8/5, so 8/5 squared minus 1/2. If we were doing this by hand, just square the top, square the bottom, and then 1/2. If I wanted a common denominator to actually clean up here, I would have to multiply top and bottom by 2, and then top and bottom by 25 over here. So 64 times 2, 128, minus 1 times 25, 25, all over a common denominator of 2 times 25, which is 50. And we can pretty quickly see letter A is the only one that takes that into account. In 22, the same thing. And I just want to show you like the calculator way. Obviously, the calculate option is going to be so nice here, because that's what it's meant to do. It's meant to evaluate. So I'm plugging in a 4/5 for x. If I were doing that by hand, I would just type in 3/2 times 4/5 plus 9/5, then follow my order of operations, cross the top, cross the bottom, plus 9/5. If I give that a common denominator, it would be 18/10. Hey, 12 plus 18 is 30/10. That answer is just 3. But in a calculator, when you type in fractions, just use grouped division. So I would type in a parenthesis 3 divided by 2, close up that fraction. Another parenthesis 4 divided by 5, plus the last fraction 9 divided by 5. See how they're all just grouped together as division? That's what I would type in. And then I would have the calculator output a fraction. And so this is just hitting the math key on the calculator, and then option 1. It shows up right away, math to fraction, and then hit enter. it'll give you a fraction answer. So if it came out messy, you'd get the fraction answer instead of the nice clean number. All right, so again, a little bit of insider perspective there. All right, 24 tends to give people some issues as well. And again, I apologize for skipping around. I just want to focus on the problem areas first and foremost. Just remember that, like with parabolas, the vertex of an absolute value function is affected by the shifts. So this is like vertex form of an absolute value. So it's going to the right 4 and up 4. And it's not vertically flipped or anything. It's going to be a V-shaped graph opening upwards. So if I go right 4 and up 4, the graph's going to go up from there. And so the range is going to be all the y values, and I see that as soon as I'm at 4, I'm going to see the graph all the heights up above it. So y is greater than or equal to 4 for that problem. All right, we're moving right through this. Remember, the exam itself is only 39 problems, so if you're looking at this, there's a lot of extra practice here. We don't repeat problems as frequently on the test. So don't feel like you're going to be rushed for time. We don't want to dilly-dally, but we're certainly not going to be rushed. All right, 25, you can see we start dealing with transformations again. So here it's given graphically. If we have the parent function for an absolute value given here, notice that the one I want is vertically flipped. It's a V-shaped graph opening down, and it's taller and skinnier. So I know that C and D are out of the question because we want it twice as tall. We want a times 2 out front. And then that vertex goes left 2 and up 3. Left 2, up 3. It has to be option A. All right, 26, same thing, shifted down 3, but half as tall. So half as tall, down 3, it has to be C. It has to be scrunched down so it looks like it's opening wider, but it's really just squeezed down with that vertical shrink. So a lot of these problems, again, you can look at for 10 or 15 seconds and kind of piece together an answer from the graph. If you were looking to show work on something like 26, I would hope on the test you wouldn't have to, but just say like half as tall, down 3, just to show me that's how you thought through the problem. That's really good. That's totally sufficient for showing me work. And then you can see a lot of the same things. We're into chapter 1 now, slope of the line, y-intercept of the line. Just remember for these, we want to set them up as y equals mx plus b so we can find the slope, find the y-intercept. So we're really just solving for y. 29, what is the x-intercept? We really don't ask that question too much in Algebra 2, but the x-intercept is when y equals 0. So if I go through this equation and I substitute in 0 for y, I find negative 20 plus 0 equals negative 2x. X has to be 10. It's a simple problem, but it's not something we've asked a whole lot this year. Another slope of the line problem. Those tend to go pretty well. You guys did a pretty good job with slope early on. Which inequality? It's that same concept of solid or dashed above or below, but to keep things a little bit easier to see the above and below, we've used a linear graph here. Basic solving equations. Solve the system by graphing. Here again, you don't even have to draw the complete graph. So plus 3, and we're at 7 over 4x. Okay, so there's that one at 1/2 x minus 2. Like you can just kind of, without even having to draw the actual lines in, you should hopefully find the clean point where they intersect. Solve the system. Again, you get to choose substitution or elimination. Pretty straightforward. Now we should be having a little bit of a, oh, okay, like the bottom one is the exact same equation as the top one. It's just everything's doubled up. So that should be an IMS, but the math would be very easy to show that everything cancels. You get 0 equals 0 pretty quickly. More solid or dashed above or below here on 35. Not much of an issue there. 36, find the value of z in the solution to this system. This is the one problem that I would say takes some time. So as we go through and do this problem, just remember we want z. So if I could set it up in a way that I do not eliminate z, that would be best. I want to keep z because that's the first thing I want to solve for. So for these first two, I'm going to eliminate the y's, and I can just combine those together right now. I would have 3x, my y's would cancel, and I'd have 4z, and that would equal 1. And in class, we would box this up. Bottom two equations, look, the y's are set to eliminate again. This is great. I get 7x, my y's cancel, I get 2z, and that equals 5. And again, I want to solve for z. So even though z looks easier to eliminate here, I don't want to eliminate it. I want to solve for it. I don't want to have to solve the entire thing. So I'm going to choose to eliminate x. And it might mean some bigger numbers to work with here, but it's going to make my workload in the end much, much easier. So I'll have negative 21x minus 28z equals negative 7. I will have 21x and then plus 6z equals 15. X's eliminate. I get negative 22z equals negative 7 and positive 15, which is 8. And I must have made a mistake somewhere. Because I'm not seeing an answer that should show up as a fraction. It should come out nice and clean. Let me just take a second and look through this. X and 2x, good. Y's cancel. Z and 3z, good. 3 and negative 4, aha, this should have been a negative 1. So this would have been a positive 7. Simple mistake early on. Negative 22z then equals 22. Divide away the negative 22, we find that z equals 1. But again, in saying, hey, I want to eliminate everything but z, that leaves me with my answer being z. I don't have to back substitute that way. So hopefully a little bit of information you can take away with you. This type of difficulty, you shouldn't expect anything more complicated than this on the test itself, but there is one that shows up like this. I do know that. All right, so for 37, the y-intercept, just like in a line, the constant for a quadratic function is its y-intercept. So 0, 17 is the y-intercept, so I'm thinking A or C. It cannot be B, and it cannot be D. So now it's just a matter of the axis of symmetry, the opposite of B. Since we're in standard form, over 2 times A, it's a negative 25 over 10, so negative 5 over 2 would be that simplified fraction. Okay, another intercept form. Again, some of this repetition you won't see on the test itself, just to keep it relatively short. 39 is another one of the more mathematically intensive ones. But if you take a look, our vertex is 2, 7, and vertex form is x minus h squared plus k. So I'm looking for an x minus 2 plus 7. So it cannot be B and it cannot be C. Just because of what was in the parentheses and outside how we plug that vertex in. We take that passes through point, the x and y, and we use that to solve for A. This is the last piece of the puzzle. We plug in everything except for A. A negative 5 squared, I got to do exponents first. That's 25 times A, positive 25. Then we subtract away the 7. And we see that our A value is going to take negative 6 and divide away 25. It has to be D. So again, so far we've had 2 problems that are really mathematically intensive. Solve by factoring again. Lead is 1, magic numbers, and done. Just make sure you're set equal to 0 first. You guys did pretty well on those trinomial factorings. I know that in geometry and in Algebra 1 they've done a great job with those. All right, taking a look at number 41. This is this is what we just got out of in chapter 3. So hopefully we notice all the parabolas are the same, except we've got some plus ones and we've got some minus ones. If I look at the vertex, that is shifted up 1. So I don't want to see minus 1 at the end of that equation or that inequality. So it has to be one of these two. The line is solid. It's shading underneath. So I want a less than or equal to inequality symbol. All right, some completing the square work. But you guys did a pretty nice job finding that perfect number to fill in the blank. That's all they're asking us to do. What perfect number goes over here? Another intercept form, just to find the two zeros. So in this case, 12 and 1, 13, add them up and divide by 2. Quadratic formula, you guys did a wonderful job with this on the last test. So those problems usually aren't too difficult. All right, 46, which equation has the following roots? This one's kind of a tricky one because we got to go backwards through the problem. So if we have roots, those mean the same thing as zeros or solutions. So what would give me a root of -2 is a factor x plus 2. What would give me a root of 2 over 3 is 3x minus 2. And so if I FOIL those back together, then I get the equation that leads me to those roots. So we have to go backwards from roots to factors to function. So if I FOIL this out, I get 3x squared. There's not a surprise. Outside is minus 2x. Inside is plus 6x. And from there, I can tell that's how I'm going to decide my answer. This is going to combine to make a positive 4x. It has to be A. Uh, 47, again, this is one I would recommend. Just go to the calculator. Don't waste your time foiling there. All right, and then there are, I believe, 4 questions at the end of the exam where you have to answer the question in grid in your response. They're not very difficult mathematically. We just want to make sure we're reading correctly. So slope of the line, you just enter that. So for this one, we have 8 minus -3, 11. 6 minus -2, 8. You could type in 11 over 8. If you had a decimal, that would be 1.375. Rounded to the nearest hundredth, we're told to get a decimal answer here. That would be 1.38. So we'd do 1.38. So just be sure we're reading instructions for how to grid in our answer. We have adjusted the key to allow for different representations. So if you could fit 11 over 8 into the boxes, we would allow that as well as 1.38. All right, 49. 3 snorkels and 1 pair of flippers was $24. 2 snorkels and 2 pairs of flippers was $26.52. What's the cost of 1 snorkel? Okay, so 1 snorkel is 1x. So we're going to solve this system for x. And this one would be good to do the elimination method. Knowing that I'm solving for x means I want to eliminate the y's. So 2x plus 2y equals 26.52. Negative 6x minus 2y equals negative 48. Get negative 4x equals, let's see, that would be what? 21.48, I believe. 47, yep. And then divide both sides by -4. And we would get our answer. So this is one where, if I divide that out, I think 4 goes into 21 5 times. 4 goes into 14 3 times. 4 goes into 28 7 times. So 537 would be the answer that we would put in that grid. Find the y coordinate of the minimum of this graph. So for this one, there's a little bit of work, right? It's standard form, so we have to do opposite of b over 2 times a. And here's where that math to fraction could be a big help to you, or we could just work with decimals really if we wanted. So I've got -3 times 7 over 10. I'm multiplying those together and then making the reciprocal of that. So this would be 10 over 7. Dividing by a fraction is like multiplying by the reciprocal. All right. And I know that because that AOS is going to pass through that vertex, I know that when I take that AOS value and plug it back in, I'm going to get the y value of that minimum point. All right, 5 over 7. I'm squaring this so it comes out positive 441 over 100. Oh boy, let's see. So we got 2,205. And we could type that into the calculator, obviously, at any point. This would probably be where I'd type it into the calculator just to get a decimal answer and just round to the nearest hundredth. That's where that 2.85 is coming from that you see in the answer key. So the numbers are a little bit nastier, but since you can use your calculator to help plug those in, the process doesn't change. That's the important thing. All right, and then lastly, how many seconds does it take for the balloon to hit the ground in this equation? So this is all we need. To hit the ground means its height is 0. So negative 16t squared plus 144. When does that equal 0? That means 16t squared. If I add that to the other side, when does that equal 144? Divide both sides by 16. I find that t squared equals 9. And if I square root both sides, t equals plus or minus 3. And I know that I can't have a negative time, so it has to be the positive 3 that I would use. And if you've taken STP math, you probably know that these gridded response questions, they don't have negative answers to them. So just be aware of that. If we're coming up with something that's looking pretty gross and negative, we may have made a mistake somewhere. So I believe that's touched on just about everything. I know this is a little bit lengthier video, but I wanted to be sure I had an opportunity to get some content to you guys, even though I'm not in the building, that would help you in your efforts to review. So I'll also be posting this video to the Google Classroom as well, so that if you're studying later tonight and want to go through something again or hear it explained again, you will be able to find that there. One last call. If you do have questions over this, please feel free to email me. I'll be available all night. Well, I shouldn't say all night, but I'll be available later tonight to help answer those questions. All right. I hope we have a great review, and looking forward to some good exams coming in tomorrow and Friday.